say a plus ib is equal to x plus iy if and only if a is equal to x and b is equal to y. So the imaginary part and the real parts are equal separately. Now equate the real parts. What are the real part? AC minus BD is the real part, and imaginary part you can take I common factor, AD plus BC. Simplify this. 1 into I is I, minus I into I is I square. So I divided by minus I square is minus 1. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, Faculty Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. Today in this session I am going to discuss regarding very important and easiest chapter, that is chapter 4, complex numbers. So this is very easiest and important chapter for the point of examination. So the weightage for this chapter is 9 marks. So you are going to get 9 marks here. So 3 marks 2 questions, 6 marks, 2 marks 1 question, 2 marks, then 1 mark 1 question. That's equal to totally 9 marks from this chapter. So the weightage for this chapter is 9 marks. So today I am going to discuss regarding definition of a complex number and the algebra of complex number. Algebra of complex number means the operations on complex numbers like addition of complex numbers, subtraction of complex numbers, multiplication and division of a complex number. So those things which I am going to discuss in this session. Now let us know regarding what is meant by a complex number. What is the definition of a complex number? So a number of the form a plus ib, that is a number of the form z is equal to a plus ib is called a complex number. A number, any number of the form a plus ib or x plus iy, we can also call it as x plus iy. Any number of the form x plus iy or a plus ib is called a complex number, where a and b are real numbers, and is a and b are real numbers is defined to be a complex number where I square is equal to minus 1. So that means I is equal to root of minus 1. The value of I is equal to an imaginary number root of minus 1. So here the set of complex numbers is denoted as C. C is the set of complex numbers and is given by x plus iy such that x and y belongs to any integer and I is equal to root of minus 1. This is called a complex number. So where x and y are any integers, so I is equal to root of minus 1 is an imaginary number. So if I is equal to root of minus 1, then I square is equal to minus 1. I square is equal to minus 1. So here A is called the real part denoted as RE of Z, real part of the complex number Z, and B is called the imaginary part of the complex number denoted as IM of Z. So the real part is denoted as RE, real part of the complex number Z, and the imaginary part is denoted as imaginary of the complex number Z. So here A is the real part and B is the imaginary part. Here X is the real part and Y is the imaginary part of a complex number. So any number of the form a plus ib or x plus iy is called a complex number, and I is equal to root of minus 1 is an imaginary value. So here for example 2 plus 3i is a complex number, 3 minus 2i is also a complex number. So here 2 is the real part and 3 is the imaginary part, whereas in this case 3 is the real part and minus 2 is the imaginary part, and the coefficient of I is the imaginary part. So the value of I is equal to root of minus 1. Now let us take a small note. Two complex numbers z1 and z2 are said to be equal if and only if their corresponding real parts and imaginary parts are equal. So two complex numbers z1 is equal to a plus ib and z2 is equal to c plus id are equal if and only if the real parts a is equal to c and the imaginary part b is equal to d. So two complex numbers say a plus ib is equal to x plus iy if and only if A is equal to X and B is equal to Y. So the imaginary part and the real parts are equal separately. Now, a complex number Z is said to be a purely a real complex number if imaginary part of that complex number is 0. If imaginary part is 0, then the complex number is said to be a purely a real complex number. If a complex number is said to be purely imaginary if the real part of the complex number is 0. If the real part of a complex number Z is 0, then it is called purely imaginary complex number. If imaginary part of a complex number is 0, then it is called purely a real complex number. Now let us call, for example, 2 plus 0i. Here the imaginary part is 0, therefore this is called a purely real complex number. This is a real complex number. Suppose if I write like 0 plus 2i, here the real part is 0, this is called purely imaginary complex number. This is an example for a imaginary complex number. So, if the real part is 0, then it is called purely imaginary complex number. Purely real means imaginary part is 0. Purely imaginary part means real part of the complex number Z is equal to 0. Right. Now, properties of complex number, addition of complex number. Let us consider a complex number. Let us consider two complex numbers. Z1 is equal to, yes, Z1 is A1 plus I into B1 and Z2 is equal to A2 plus I into B2. These are the two complex number. Then the properties of complex number, in that first one is the addition of complex number. So addition of complex number, let us add the two complex numbers Z1 and Z2. What is Z1? Z1 is A1 plus I into B1. Z2 is A2 plus I into B2. Now just add the real parts, A1 plus A2 plus I into B1 plus I into B2. You can take the common factor, A1 plus A2 as it is, plus I is out, B1 plus B2. So therefore this is again of a form A plus IB. So where A is equal to, we can write where capital A is equal to A1 plus A2 and capital B is equal to B1 plus B2. That means again if you add any two complex number, you are going to get a complex number. So addition of a complex number is again a complex number. This is again a complex number. That's it. So if you add two complex numbers, you will get a complex number. So addition of a complex number is again a complex number. Let us consider for example, if Z1 is equal to 2 plus 3i and Z2 is equal to 3 plus 4i, then if you add Z1 plus Z2, what is Z1? 2 plus 3i plus Z2 is equal to 3 plus 4i. Add the real parts. So what are the real parts? 2 plus 3 plus imaginary parts 3i plus 4i. Now what is this equal to? 2 plus 3 is 5, 3 plus 4 is 7i. So again this is of the form x plus iy, a complex number. Real part is 5 and imaginary part is 5. That's it. This is how we are going to add the complex numbers. So this is called addition of complex numbers. Now the second one is difference of two complex numbers. So if you subtract, difference of two complex numbers is the subtraction. That is, let us consider Z1 and Z2. If Z1 and Z2 are any two complex numbers, that is, what is Z1? Z1 is equal to A1 plus I into B1. What is Z2? Z2 is equal to A2 plus I into B2. So if Z1 and Z2 are any two complex numbers, then the difference of these two complex numbers is denoted as Z1 minus Z2 and is given by Z1 minus Z2 is equal to Z1 plus of minus Z2. So therefore we can write Z1 minus Z2 can also be written as Z1 plus minus of Z2, or straight away you can write what is Z1? A1 plus I into B1 minus what is Z2? A2 plus I into B2. Now this can be written as A1 plus I into B1 minus, just multiply by negative sign, minus A2 minus I into B2. Now equate the real parts, that is A1 minus A2, subtract these two, plus I is a common factor, B1 minus B2. So this is again of the form A plus I into B. What is A? The real part is A1 minus A2 plus B, the imaginary part is B1 minus B2. Again this is a complex number, right? So the difference of a two complex number is again a complex number. So if you add complex numbers, you will get a complex number. If you subtract, you are going to get a complex number itself. So the difference of a complex number is again a complex number. Now what is the third property? So third property, if Z1 is equal to A plus IB and Z2 is equal to C plus ID, let us assume Z1 and Z2 as A, B, C, D. Then we any two complex number, then the product of these two complex numbers is denoted as Z1 and Z2 and is given by Z1 into Z2 is equal to A into C minus BD plus I into AD plus BC. Or we will get, just multiply this. So what is Z1 into Z2? Z1, the complex number Z1 is nothing but A plus I into B and the complex number Z2 is C plus I into D. Just multiply it. So this is A into C plus I into A into D. Again I into B into C plus I into I is I square, B into D is BD. Now since we know the value of I, what is I? I is equal to root of minus 1. If we square, I square is equal to minus 1. Substitute I square is equal to minus 1. This is AC plus I into A into D plus I into B into C. Since I square is equal to minus 1, minus into plus 1, it is minus 1 into BD. So I square is minus 1, plus into minus, it is minus. Now equate the real parts. What are the real part? AC minus BD is the real part and imaginary part you can take I common factor AD plus BC. Again this is of the form X plus IY, a complex number. So that means this is called multiplication of a complex number, very important. So multiplication of a complex number and division of a complex number is very important for the point of examination. First multiply these two, A into C, again A into this, again I into B into C, I into this. So I into B into D, that means A into C AC plus I into A into D. Again from B, I into BC plus I into I is I square, B into D is BD. Now I square, what is I square? I square is equal to minus 1. Equate the real and imaginary parts, the real parts of AC minus BD and imaginary parts of AD plus BC. So AC minus BD plus I into AD plus BC will gives a complex number. This is called the multiplication of two complex numbers. Now next one is properties of product of complex numbers. Let us take an example for this. For example, let us take if Z1 is equal to 2 plus 3i and Z2 is equal to 3 plus 4i or any two complex number. If you multiply Z1 into Z2, what is Z1? 2 plus 3i into Z2 is 3 plus 4i. So just multiply, 2 into 3 is 6, again 2 into 4 is 8i, again 3 3s are 9i plus 3 4s are 12, I into I is I square. Since I square is equal to minus 1, this is 6 plus 8i plus 9i, I square is minus 1, this becomes minus into plus, it is minus. Make a group of real parts, 6 minus 12, I common factor 8 plus 9. What is this equal to? 6 minus 12 is minus 6 plus I into 8 plus 9, 17. So minus 6 plus I into 17 is a complex number, or if you want you can also write like this, minus 6 plus 17i is a complex number. Okay, now let us take one more example. If Z1 is equal to 2 minus 3i and Z2 is equal to 2 plus 3i, then what happens? Z1 into Z2. Z1 into Z2. Z1 is 2 minus 3i into 2 plus 3i. So multiply, 2 into 2 is 4, 2 into 3 is 6i, again minus 3 into 2 is 6i, minus into plus minus 3 3s are 9i square. Since this is 4 plus 6i minus 6i, I square is equal to minus 1. Minus 6i plus 6i gets cancelled, 4 minus into minus plus 9, that's equal to 13. This can also be written as 13 plus I into 0. Again this is of the form x plus iy a complex number. So if x plus iy is a complex number, then x minus iy is called the conjugate. That we will explain. So if a complex number, if it is a conjugate pair, 2 minus 3i and 2 plus 3i are the conjugate pair. So if you observe carefully, this is of the form a minus b into a plus b. A minus b into a plus b is nothing but a square minus b square. So 4 square, 2 square is 4 minus 3i whole square is 9i square is equal to minus into minus becomes plus, 4 plus 9 is equal to 13. So you will get a purely a complex number. Okay, this is how we are going to multiply any two complex number. Now addition, subtraction, multiplication. The next one is the division of a complex number. So the division of two complex number. Let us consider two complex numbers z1 and z2. If z1 and z2 are any two complex numbers and z2 is not equal to 0, then z1 by z1 is defined by z1 by z1. That's equal to z1 into 1 over z1. Or we can also write, or if you want, z1 by z2 can also be written as z1 into 1 by z2. Okay, or if you want z2 divided by z1, if you divide z2 by z1, we can also write z2 into 1 over z1. Here in this case, z2 is not equal to 0, here z1 is not equal to 0, right? Okay, now this is how we are going to divide a complex number. Let us take an example. Example, 2 plus 3i divided by 1 plus 2i. Suppose if you want to divide a complex number, so this can be divided by the method of rationalizing the denominator. So this complex number 2 plus 3i divided by 1 plus 2i multiply and divide by 1 minus 2i by 1 minus 2i. That is rationalizing the denominator. Multiply 2 into 1 is 2. Again minus 2 into 2 4i. Again plus 3 into 1 is 3i. Minus 3 2s are 6. I into I is I square divided by 1 into 1 is 1 square, plus into minus minus, this is 2i whole square. So since you know I square is equal to minus 1, substitute here, this is 2, minus 4i plus 3i is minus I square is equal to minus 1, minus into minus becomes plus 6, 1 square is 1, I square, this is 4i square, 4 into I square is minus 1, minus into minus it becomes plus 4. So therefore this can be written as 2 plus 6 is 8 minus I divided by 1 plus 4 is 5. This can be written as 8 by 5 minus I into 1 by 5, again a complex number. This is how we are going to divide a complex number. This is very important concept. For division of a complex number, just rationalize the denominator. Hope you followed. Now move on to the next concept, powers of I. Now, so what are the powers? This is very important. What are the powers of I? You know, I is equal to root of minus 1. Therefore, if you square, I square is equal to minus 1. What is I cube? I cube can be written as I square into I. What is I square? Minus 1 into I, that's equal to minus I. I cube is minus I. I to the power of 4. I to the power of 4 can be written as I cube into I. What is I cube? Minus I into I, that is minus I square. I square is minus 1, minus into minus plus. Or you can also write like this. I to the power of 4 can be written as I square into I square. What is I square? Minus 1 into minus 1. That's equal to plus 1. Okay, suppose if you want I to the power of 8. I to the power of 8 can be written as I square whole to the power of 4. What is I square? Minus 1 whole raised to 4. If you multiply minus 1 4 times, you will get plus 1 itself. Suppose if you want I to the power of 12. I to the power of 12 can be written as, yes, this can be written as I to the power of 4 whole to the power of 3. I to the power of 4 whole raised to 3. 4 3s are 12. What is I to the power of 4? I to the power of 4 is equal to plus 1 whole cube. So plus 1 whole cube means 1 into 1 into 1 it is plus. So this is how we are going to simplify. Now let me explain. Standard identities of the complex number. So here if z1 and z2 are any two complex numbers, then z1 plus z2 whole square is z1 whole square plus 2 z1 z2 plus z2 whole square. That is nothing but a plus b whole square, a square plus 2ab plus b square, same. So z1 square plus z2 square plus 2 z1 z2. A minus b whole square, z1 minus z2 whole square is z1 square minus 2 z1 z2 plus z2 square, or a minus b, a square plus b square minus 2ab, that is z1 square plus z2 square minus 2 z1 and z2. z1 plus z2 whole cube is nothing but z1 cube plus 3 z1 square into z2 plus 3 z1 into z2 whole square plus z2 cube. Suppose if it is like this, z1 plus z2 whole cube. So this can be written as z1 plus z2 whole cube is z1 cube plus z2 cube plus, yes, 3 z1 into z2 times z1 plus z2. So this is 3 z1 square into z2 plus 3 z1 into z2 square. Similarly, if you want z1 minus z2, z1 minus z2 whole square can also be written as z1 cube minus z2 cube plus 3 z1 into z2 whole square minus 3 z1 square into z2. This is how we are going to expand. So z1 cube minus 3 z1 square into z2 plus 3 z1 z2 square minus z2 cube. Now similarly, if it is of the form z1 square minus z2 square, a square minus b square is nothing but a plus b into a minus b, z1 plus z2 into z2 minus z1. So z1 square minus z2 square is equal to z1 plus z2 into z1 minus z2. So these are all of the forms like a plus b whole square, a minus b whole square, a plus b whole cube, a minus b whole cube, and a square minus b square. Based on this, we are going to expand, that is a complex number. Now, next, just express the following. Let us move on to the simple problems. The problems for 1 or 2 marks. Express the following in the form x plus iy. So, express the following in the complex number x plus iy. What is the problem given? Minus 5i into 1 by 8 times I. So the given equation can be written as, given equation is minus 5i into 1 over 8 times I. Now just multiply it. Minus 5 into 1 is minus 5. I into I is I square divided by 8. So minus 5 into I square. Since I square is equal to minus 1. This is minus 1 divided by 8, minus into minus plus 5 by 8. So this is nothing but 5 by 8 plus I into 0, a complex number of the form a plus ib. That's it. See, minus 5i into 1 over 8i, minus 5 into 1 is minus 5, I into I is I square divided by 8. I square is equal to minus 1, minus into minus plus 5 by 8. 5 by 8 can also be written as 5 by 8 plus I into 0, where 5 by 8 is a real number, real part, and imaginary part is 0. This is purely a complex number, pure complex number. So therefore, this is of the form a plus I into b. A plus I into b, where a is equal to 5 by 8 and b is equal to 0. That's it. Now, next one. 2 plus I into 3 plus minus 6 into I into 5. So this can be written as 2 plus I into 3 plus into minus minus 6 plus into plus plus I into 5. Just equate the terms containing the real part 2 minus 6 plus I common factor 3 plus 5. So this is 2 minus 6 is minus 4, 5 plus 3 is I into 8, or this can also be written as minus 4 plus 8 time. Right. This is how we are going to add this complex number. This is nothing but addition of a complex number. Now move on to the next one. I to the power of minus 39. Now I to the power of minus 39 can be written as I to the power of minus 39. So 1 over I to the power of plus 39. So split this. You can split. So this can be written as I to the power of 36 into I to the power of 3, I cube. 36 plus 3 is 39 according to law of indices. What is law of indices? A to the power of m into a to the power of n is a to the power of m plus n. I to the power of 36 into I to the power of 3 is equal to I to the power of 36 plus 3. You can write I to the power of 39. So simplify this. 1 over, what is I cube? So you know I cube is equal to I square into I. I square is minus 1 into I is minus I. Now I to the power of 36. I to the power of 36 can be written as, so we can write this as I to the power of 4 whole raised to 4, 9. 4 9s are 36. You know what is I to the power of 4? I to the power of 4 is I square into I square. Minus 1 into minus 1, this is plus 1. 1 to the power of 9 is equal to 1. So I to the power of 36 is 1. So substitute here, I to the power of 36 is 1 into I cube. I cube is equal to minus I. 1 divided by 1 into minus I is minus I. So 1 divided by minus I. Rationalize this. 1 divided by, for minus I, just multiply and divide by plus I. So I divided by I. Simplify this. 1 into I is I, minus I into I is I square. So I divided by minus I square is minus 1. So I divided by minus into minus plus 1, I by 1 is equal to I. So the simplified answer is I. I to the power of minus 39 is also equal to I. So therefore, I to the power of minus 39 is also equal to I itself. That's it. Okay. See, very simple. See here, 1 over minus 39 can be written as plus 39. 39 can be written as 36 into I to the power of 36 into I to the power of 3. 36 plus 3 is 39. Since I to the power of 36, you can split like anything. So depending upon your calculations, so I can split I to the power of 36 as I raised to 4 whole raised to 9. 9 4s are 36, right? So since you know I to the power of 4 is plus 1, if you multiply 1 9 times, you will get 1 itself. So therefore, 1 divided by I to the power of 36 is 1 into I cube is minus I, 1 by minus I. So that is minus 1 by, rationalize the denominator, just multiply by 0 plus I, that means I, multiply and divide by I into 1 is I, minus I into I is I square, since I square is minus 1, minus into minus plus I divided by plus 1 is plus I itself. So therefore, I to the power of minus 39 is always equal to plus I. That's it. Now move on to the next problem. 5 plus 2i divided by 1 minus 5i. So this is again nothing but the given equation is of the form 5 plus root 2 into I divided by 1 minus root 2 into I. Rationalize this. So this is 5 plus root 2 into I divided by 1 minus root 2 into I. You know the division of a complex number is done by rationalizing the denominator. Multiply by 1 plus root 2i divided by 1 plus root 2i. What is this equal to? Multiply it. 5 into 1 is 5 plus 5 times 5 into root 2 times I. Again, root 2 into 1 is root 2 times I. Again, plus root 2 into root 2 whole square. Square root gets cancelled. 2i into I is I square divided by denominator. 1 into 1 is 1 square. Again, minus root 2i into root 2i is root 2i whole the square. Since I square is equal to minus 1, you can write 5 root 2 plus root 2, 6 root 2. 6 times root 2i. I square is equal to minus 1. It becomes minus 2 divided by 1 square is 1. Root 2 whole square is 2 into I square. So 5 minus 2. 5 minus 2 is 3 plus 6 root 2 times I divided by I square is equal to minus 1. Minus into minus becomes plus. So this is 3 plus 6 root 2 I divided by 2 plus 1 is 3. You can take the common factor in the numerator. 3 is the common factor. 1 plus, so you can write 2 root 2 into I divided by 3. 3 gets cancelled. So therefore, the simplified answer is 1 plus 2 root 2 into I is the simplified answer. So the simplified answer for this is 1 plus 2 root 2 into I. That's it. 1 plus I into 2 root 2 or 2 root 2 into I. In some textbook they may represent like this. 1 plus I into 2 root 2. One and the same. Right. That's it. So this is how we are going to simplify. These are called the properties of complex numbers. That is the operations on complex number: addition, subtraction, multiplication and division. Addition of a complex number is again a complex number. Difference of a complex number is a complex number. Multiplication of a complex number is again a complex number. If you divide, again you will get a complex number. So these are very important properties of a complex number. So hope you followed, right? So that's all regarding today's session. Let us meet with a different concept in the next session. Thank you very much.